Okay, these are notes 3.4. We're going to talk about a margin of error. And we're going to estimate a margin of error for a sample proportion and also for a sample mean. Okay, so let's talk about what a margin of error is. So I just looked up a poll. It was done by NBC, I believe, or at least it was reported by NBC. I'm not sure who did it. Trump's approval rating was 37%. Okay, so what happened was they took all of the United States and they took a sample, and I'm not sure what the sample was. Usually it's around 1,500 people, maybe even more. Okay, and from that sample, they estimate that 37%. Well, from that sample, they had 37% approve of Trump's job. Okay, what he's done in the office. So 37% approve. Now, that had a margin of error of 3.5%. Okay, so what does that mean? So do we really know what the whole United States believes? No. We took a sample of, say, 1,500 people, and we got an estimate. Okay, we believe it's 37%. Now, what we do here is we create a margin of error. Okay, so we believe, based upon the sample size and some other things, which we'll get into another chapter, we're just kind of doing the basics here, we believe that it's within 3.5%. So I can add 3.5% this way, and I can subtract 3.5% this way. Okay, so if I take 37 and add 3.5%, I get 40.5. And 37 minus 3.5% would be 33.5. So what we're saying here is we believe the whole United States, based upon this sample, we believe the whole United States is this, but maybe it's between here and here. Okay? So that's the idea of a margin of error. We believe that the error, okay, so just based on our sample, there could be some error with that. But we believe the true U.S. population approval is between this number and this number. Okay? That's our margin of error. So can we say that we are pretty sure that less than half of the people don't approve? Yes, we can, because 50% is not in there. Now let's just say that the approval rating was 48%, plus or minus 3.5%. Okay? So now, if we took a sample and it was 48%, and I add 3.5 to that, it'd be 51.5, and I subtract 3.5, that'd be 44.5. Okay? So now, our margin of error, we believe the true number is between this number and this number. Now, from our sample, less than 50% approved, but within our margin of error, could it maybe be over 50%? Yeah, it could. Okay? So that's the whole idea of a margin of error. Okay, to use some examples from the book, most common uses of statistics is to estimate a proportion of an individuals in a population. So statistics, the whole idea of statistics is to take a whole population, look at a sample, and apply it to the whole population. Okay? So for example, what proportion of students at your school text during class? What proportion of U.S. residents approve of the job performance of the president? So to make a good estimate for the whole population, we start by taking a random sample of the population, and then from that we can develop a margin of error that we believe it to be between. So a definition of margin of error is an estimate describes how far, at most, we expect the whole population value to be. So we believe the whole population to be somewhere between here and here. This was our sample, but the whole population we believe to be between these two numbers. Okay? So let's look at this example. So Carolina selected a simple random sample of 50 students from the 2,000 students at her high school and asked each student to fill out a survey about texting during class. Overall, 64% of the students admitted that they texted during class. Thus, she believes the proportion for all the students in the school is around 64%. Okay? But with a margin of error, It might be more, it might be less than that. We don't really know what the true population is. So what we're going to do is this is how the book wants you to do. I'm not going to get into this part here, but basically what it wants you to do, to get the margin of error, you're going to take 2 times the standard deviation. Okay? So we're going to say our margin of error is equal to 2 times the standard deviation. Okay? So if we look at this example here. So in March 2014, the Gallup poll organization surveyed a random sample of 1,500 adults. So there's that number, 1,500. It's a magical number a lot of times. And overall, 42% of the people sampled approved the way Obama handled his job as president. The dot plot, okay, so we have an estimate of 42%. Okay? Now, we're going to add and subtract our margin of error. And the way we find our margin of error is to take 2 times the standard deviation. And it'll give you the standard deviation. I'm not going to make you figure it out. Okay? So we're going to that standard deviation right there. So if I take 2 times 0.013, I get 0.0. Yeah, I should have done that without a calculator. Okay? So I believe it's 42% plus or minus 2.6%. So 42% plus 2.6% gives me 44.6. And 42 minus 2.6 gives me 39.4. So we had an estimate from our sample of 42%, but we believe the whole population is going to be between 39.4 and 44.6, somewhere in there. Okay? So our margin of error was 2.6%. And then the interpretation, we expect the true proportion of all the whole population of adults who approve of Obama's job performance to be at most this far away from here. So at most that far away. Okay? Between there and there. Okay? Notice, okay, so let's talk about this too. Margin of error was a lot smaller here than the previous person, right? So in her, she only took 50 students. Okay, Carolina with the texting. She took 50 students, whereas this one took 1,500 adults. So which is going to be more accurate, a smaller or a larger? Okay, the larger is going to be more accurate, right? So another important point here. The larger the sample, the smaller the margin of error. Okay, and vice versa. If I take a small sample, it gives us a larger margin of error. Okay, so that's something that you should definitely have there. Okay, now that was with proportion, right? We're talking about percentages. Now we can also switch to finding the mean. Okay, so let's say we want to know the average number, the mean number of hours that students in our school typically sleep. Okay, so she once again took 50 students from her school, and this is what it was. And it had a mean of 7.24. Okay, so 7.24 is our sample. Okay, we have the whole school. Spell it right there. Okay, the whole school, she takes a sample of 50 students, and the number of hours of sleep they got had a mean of this. Okay, now, once again, our margin of error is going to be this number. Sorry, our confidence interval is going to be this number plus or minus our margin of error, which is going to be 2 times the standard deviation of these numbers. Now, you know how to find standard deviation of numbers. We've done it in Desmos, right? We also did it by hand, which was, kind of a pain. But what we're going to do is we're going to go with what they give you. Okay? So the standard deviation is 0.146. Okay? So if I take 7.24, well, let's multiply it together first. So I take 2 times 0.146, and I get 0.292. Okay, so remember, we're not talking about percentages now. We're talking about the mean number of hours of sleep. So my confidence interval would be 7.24 plus 0.292, which is 7.532. And the other end of the spectrum, 7.24 minus 0.292, and we get 6.948. So we believe for her school that the mean number of hours of sleep people get are somewhere between this number and this number. Her sample was this number, but we believe the whole school to be between these two numbers. Okay, here's another one. The level of dissolved oxygen in a river or stream is the important indicator of water's ability to support life. So are fish going to die or not? A researcher measures the level at 15 chosen locations along a stream, and here's that data. Okay. Now, you could put this into Desmos, find the mean, and find a standard deviation. Okay. But it gives it to us here. The sample had a mean of this, and then we have to add and subtract the margin of error, right? So that margin of error, once again, we're estimating is 2 times the standard deviation, which is that number right there. Okay, so 2 times 0.246 is 0.492. So we're going to take this number plus and subtract it 0.492. So 4.77 plus 0.492. So on the top end we have 5.262, and 4.77 minus 0.492 gives us 4.278. So we believe the river is going to be somewhere between there and there. Okay, our samples gave us this mean, but we believe the whole river is going to be between here and here. Okay, now what if we believe that the river let's believe that the oxygen level below 5 puts the aquatic life at risk. So if we have this range, we got a sample that was below 5, but can we guarantee that our whole population, the whole stream, is below 5? Nope, because 5 is part of here, right? It could be 5.2. Okay, we're not sure. The whole population could be above there, so that's getting at that idea there. So we don't know for sure. Okay, last example. Can you roll your tongue? Okay, can you do this? Yeah, my wife can't as much. I can. My parents, they can't. My kids, they can, I think. Anyway, so they want to know the proportion of students at their school that can roll their tongue. They took 100 students and asked them to roll their tongue, and 70 could. So 70 out of 100 would give a proportion of 70%. Okay, so we have an estimate of 70% of a proportion. To find our interval, we're taking 2 times our standard deviation. Okay, so 2 times 0.048 is 0.096. Okay, so 0.7 plus 0.096 gives me 0.796, and subtracting it gives me 0.604. Okay, so we believe the true population of everyone in the school that could roll their tongue was somewhere between this number and this number. So could we say with a lot of confidence that over half the people can roll their tongue? Yeah, because all these numbers are over half, over 50%. So we can say that we're pretty confident that more than half the people in the school can roll their tongue. Okay? Can you roll your tongue? Okay, let's answer this question. Javier's biology teacher claims that 75% people can roll their tongue. Would you believe that's plausible? Is that possible? Okay, is 75% a plausible number? Yeah, 75% within this range, so it's plausible. We don't know for sure it's that, but it could be. Okay, what if you said it was less than 50%? No, we would say that's not possible because they're telling a lie, because we believe it's between these two numbers. Okay. Another thing to be careful of here. Okay, asking this: how could he decrease the margin of error? If I want to be more accurate and not have as much error, what could I do? Remember, if we want a smaller margin of error, I just have to collect a larger sample. So instead of collecting samples from 100 students, go 200 students or 300 students. Okay, that's the way I can get a decrease in the error. Okay, that's notes 3.4.